So this is our final video on this generalized theory of electrical machine. So here I am going to discuss chiefly two topics. One is that balanced steady state voltage equation. What would be our steady state voltage equation or balanced condition? Right. Now, if the three-phase system is symmetrical, if it is balanced, then it is symmetrical. Don't get confused between balanced and healthy system. Even this faulty system could be balanced. The condition of being balanced is just all the phases are carrying identical value of current or experiencing identical amount of voltage drop. It has nothing to do whether the drop is within the permeable limit or it is beneath that, it is due to the fault or it is due to some unbalance, some means undesirable factor. It is not our means not our consideration. What we consider here is chiefly whether all the phases are carrying same current and all the phases, the voltage drop across all the phases are same or not. This is the only thing that means that is our concern here, nothing else. Stating that, now let us try to analyze what our system will be in a balanced condition. If the steady state current and voltage will be same, and also don't get confused that in case of fault we can't have steady state, means although apparently these two are a bit contradictory, like fault means something very unsteady or means something means undesirable things are happening, but after means the faults take place, after occurrence of that faults, if you allow the system to means sufficient time without taking any other measures or any action to disconnect the fault, then the system reaches its new steady state with that fault. Although it may happen that the state at which the system reach the new steady state is totally undesirable one, and if you allow that system to work or to means be in that condition for a prolonged period of time, it will cause a permanent damage to your system, but still it is the steady state as long as you if you give the system for time constant, if you wait or means before clearing the fault, if you already pass 4 time constant and allow the system to reach its steady state, then it is the steady state condition. Although the system is everything is in abnormal state, but it is in steady state, and it may happen that the fault is symmetrical, like three-phase fault. Suppose in your overhead line, they are due to some accident, all the three-phase get short-circuited, or three-phase to ground fault, all the three-phase terminals due to some means thunder stroke or some other means hostile wind gust, all the one pole of that electric transmission line carrying tower got uprooted, and all the three phases are now connected with your earth and they form a triple LG fault. In that case also your system will carry excessive high current, but if you allow your system for time constant, the system will reach its new steady state. Now, in the steady state, the voltage A is, we can write now, as this is phasor, in steady state condition, we can write that VAS is equal to this lambda S is the means it is clearly this, we have already discussed how in steady state P can be replaced by our P, that is basically d to T, becoming j omega E, right? So that discussion we have already considered. Now what we are getting here, this case, for this is for inductive element, this is for resistive element, this one is for inductive element, obviously pure, and for capacitive element, although capacitive element are very rare in means application, especially in conventional way, we find a very small amount of capacitor is present, but still. So what is QAS? QAS is so it is clear that whether we take all of these three or some of them, it is always in common form. What we can write is that right, where ZS is the impedance of each three phase. Why we are assuming this? Since the circuit is balanced. Now, for equal resistance in each phase of the circuit, the balanced steady state voltage equation for QS variables in all asynchronously rotating reference frame, we can write it like for linear symmetrical inductive element, the steady state QS voltage, what we can write? The steady state voltage will be should it be QS or DS? It should be DS because we know that in inductive element always the quadrature voltage, sorry, quadrature flux linkage that affects the most. Plus there will be one more component, that is this is our kind of uh, speed, and this is our transformer EMF will be this much. The first one is speed EMF and the second one is our transformer EMF. Now this omega E minus omega factor comes due to the steady state variables in asynchronously rotating reference frame, and this varies at frequency corresponding to, it is just like that slip frequency. This term is just like that slip frequency for your induction machine. So what you can have here is that so that gives us what? Similarly, we can do it for linear capacitor element. So I hope this gives you an idea that how we should deal with the circuit. Finally, doing all this, what you will get is that now we are going to discuss perhaps the most important and insightful topic here. Since very beginning I am telling you that the main utilization of this is like transforming AC into DC and making our analysis simpler. But how we could do it, I didn't describe it. As of now, I have not provided a detailed description, but now I am going to show you that exactly how things can be simplified in that rotating reference frame. So to start, let me write, let us consider RL circuit, not to confuse ourselves with presence of C, that is totally useless. In most of the cases, considering C is not worthy. So here RL circuit we are considering in arbitrary reference frame. In addition, we assume this self means resistance and the self inductance, these matrices are diagonal matrix. Right. Now, each with equal non-zero elements and applied voltage, we can write the applied voltage in the form now here this omega E is an unspecified constant. The currents which we assume to be 0 at t is equal to 0 is like if you are getting confused, I request you to visit that transformer transient part that will help you greatly here. And where our ZS is equal to and before I change this Encodu sheet, let me just write it everything here. So if we are trying to find out the current at the first instance, it may appear to us to solve this equation to figure out the value of current. But our objective is that without solving, and even if we want to solve it in such a way that it appears like a DC signal, and thereby we could avoid unnecessary complexity of this one. So what we can do here is that to obtain this expression for the currents in the arbitrary reference frame, what we can do is that we can do some or we can apply some transformation to the arbitrary reference frame. Now for an example, we can consider if W be an unspecified constant with theta naught is equal to 0 and theta is equal to omega t, then what would happen? Let us consider a particular case that theta 0 is equal to 0 and theta is equal to omega t. So what we will get, IQS will be root 2 by Vs mod Zs E minus T by tau cos omega t minus alpha plus cos of omega e minus omega t plus minus alpha, and IDS will be minus E minus tau right. So clearly the state of this electric system is independent of the frame of reference from which it is observed, although the variables that are going to appear differently in different reference frame, and therefore they will exhibit different tendency. What I am trying to say, which area means you can select any value reference frame, and by selecting a reference frame you cannot control the physical behavior of the circuit. But why we are doing all this? The idea behind doing all this transformation and this is to visualize without doing much hassle, or means kind of hassle free, and without not investing much time and effort, we can figure out the solution in even if not solving the exact one, but solving something in a reference frame that is rotating in such a way that circumvents some complicated or precisely appearance of some complicated terms in the equation in that particular reference frame, right? So here if we see the equation, they are like the transformer. These terms are representing your transient part, and there is another term that is for our steady state part. Now in this variable set, what we can also understand that qs variable will lead ds variable. When if omega greater than 0 and qs will lag if omega less than 0, right? Now the second balance set here, which represent our steady state response, has it constant dependency or a constant amplitude with a frequency corresponding to two different angular frequency of the applied voltage. One is in the stationary circuit and the another angular velocity of the arbitrary reference frame. So this difference is between the reference axis and the arbitrary rotating reference frame. Now, if that is the case, then if what we can do is that we can make omega is equal to omega e to completely just blow out that the presence of that frequency dependent term in our representation. So this is of course the concept of negative frequency when relating to phasors which represent qs and ds as variables. Now there are two frames of reference which do not contains both balance set, i.e. the stationary reference frame, and the, if we consider omega is equal to 0, then what we will get? So if you set omega is equal to 0, then clearly this will give you something as this terms will become constant terms, and these uh, this will give us a very interesting pattern. Just let me insert the diagram. So this is our stationary three-phase system in stationary reference frame. So what we can observe here, that exponential decaying balance set becomes an exponentially decay and constant amplitude balance set that varies at omega e. In the synchronously rotating reference frame, your omega, this is one case, this is one sort of diagram. Just let me insert the another set where your previously was for omega is equal to 0 and this is for omega is equal to omega e. So the electric transients can be represented by an exponentially decaying balance set varying at omega e and constant amplitude as becomes constant. What is that? The waveform of the system variable is various reference frames we have shown here. One is this one that I discussed. This is variable of stationary system in stationary reference frame. So we can see what is the case, and also the first one is VQS, VIQS, VDS, IDS, and then what about the power? There is some oscillation in the power, and then at steady state it reaches the steady state condition. Here the problem, if you with stationary reference frame means you do not do any transformation. You can easily spot that it is clearly not symmetrical. But to solve this, you need some extra means computational effort. Whereas if you allow it to rotate in that way, then what you will get? You will get a very striking result. Here you can see that although the diagram is not very clear, we can let me write. It is our VQSE, this is IQSE, now here what you can see that VQSE is fixed and it has become 10 volt. Why so? Because here we are doing it for Vs is equal to 10 by root 2 volt. This simulation I have taken it from the book of P.C. Krauss. I am discussing on the variable that the legendary author has selected for us. Sometimes we should refrain ourselves from doing or showing our own skills and study. It is or it was, and this book is still a kind of timeless classic. So we should not try to modify what is written there. So with that, the response for t greater than 0 of the electric system in the stationary reference frame. Which one is the stationary reference frame? This one is the stationary reference frame. Here we can see that as we have selected your theta naught is equal to 0, that means the arbitrarily rotating reference frame is always starting, it starts at 0. What we are having here is that right. Well, so let me insert another diagram. These three, without comparing these three diagrams, our means discussion will not be complete. This is with respect to a stationary reference frame, particularly saying what we did during that case of transformer transient analysis in primitive form. Even after knowing this rotating means generalized theory of electrical machine, here also we are trying to follow the same type of pattern. Now what we can see here that now if we select the second case where it is synchronously rotating, which I have discussed in this one, here it is rotating at a synchronous speed, and here you can see the values of the variable VQS is equal to 10 volt and VDS is equal to 0 volt. And that is quite obvious, because if we consider the equation from which we form this VQS and VDS, what is that equation? That equation is yeah, this one. So from this what we can see that VQS is something where we must have our induced EMF, but VDS, in case of this balanced winding, VDS voltage value is 0. Yeah, this one VDS is 0. This is, we are talking about synchronous rotating frame, and here the essence is that the machine arbitrary reference frame is rotating in the direction of rotating MMF produced by our stator winding. Both of them are rotating in same direction. Therefore, the value of relative slip is 0, and that has made our VDS is equal to 0. Now, what we are having? We are having our IQS and IDS, and for that, what we have learnt in our circuit theory we can apply, and we can figure out the value of the current. So you may ask me that what is the essence? The essence is quite clear. Here you can see that VQS and VDS, both of them are DC. Unlike here, both of them are AC, and you need to do this analysis based on AC analysis. But here what you can see in the next figure, that if we allow our rotating machine reference frame, arbitrary reference frame, that is purely in our mind, to rotate at a speed of synchronous speed and rotate in the same direction, like it is not like this plus 377 we allow it to rotate in minus 377, it is plus 377, and then you can see that the two voltages appear as a direct current voltages, and that is the biggest advantage of having this type of. And another completely opposite things what you can do is that intentionally creating trouble for yourself is where you select all these, but you select omega E. Now for the last picture it was omega is equal to plus 377, and here we will consider omega E is equal to minus 377 radian per second. So if the machine motor is rotating in certain direction, you are asking your people to rotate the motor in opposite direction. So that is quite a case here. You can see the frequency has become double of the frequency. Here you can see VQS and VDS. All these frequency are becoming double, and therefore some transient behavior is also very uh, they have produced, the book has produced noteworthy observations, but otherwise meaningless, like no one is going to select a reference frame that may cause trouble, but he knows that someday we will read this book and we may have a tendency to make intentional mistakes. So he in order to make us understand, in order to make it lucid, he vividly described or means presented this diagram for us to understand that what would happen if we just try to rotate omega E or the arbitrary reference frame in opposite of your main fundamental uh, means synchronous frequency, right? So that's all, and we will use these skills to understand our generalized model of synchronous machine and induction machine. Although I have uploaded them somewhat early, but I'm going to put some indexing kind of things I'll do, so that you can figure out that which generalized machine video you should watch later, which one is most important for your case, right? And only now we have only one module remaining, that is the very small scale special machine where we have BLDC and this. I'm trying to cover everything by tomorrow, as it is already by today actually. uh, so that's all. Well, one more thing I forgot to mention, that you may find all this concept a bit tricky. Don't get disappointed and don't think that if you do not understand each and every bit of it, you will be in soup. As I said in my last video, that just don't try to learn it from online available media. If the medias are not, or videos are not from a credible person or a credible organization, try to avoid learning from those videos and try to get back to me as soon as possible, so I can help you and make you understand what all these stands for, and you'll find it really very easy. And This try to follow that indexing, otherwise you will be lost in that number of videos.